even for an extremely simple game like this one, where you can just click a ball and make it disappear, the code gets quite difficult to get a quick overview of. There's a lot of lines here. We have more than 50 lines already. So to get an overview and get to understand the code without having to read every single line, we often use state machine diagrams. And here I just want to give a quick introduction. Here's a diagram for this game. And state machine diagrams are very much in family with activity diagrams. And we can see here we have all the functions in the code. We have a start function, this one. We have the start ball falling, that one. We have the stop ball falling there. And we have the restart ball falling. So every single function is kind of drawn as this state in the program. And inside the state we write what happens here, and start, it just starts the game. There's nothing really going on here. And start ball falling, that starts the animation falling on the ball. Sometimes we write start animation falling. Say we could write start animation falling on the ball, but since we don't only have the ball, it doesn't really matter in this example here. And we don't write all the other stuff like console log, and we also don't write the event listeners, because that says here that's next to the line that brings us to the next function. The first, from start to start ball falling, there's nothing there because it's just called directly from the function. But here it says click on ball. So click on ball would bring us from the start ball falling to the stop ball falling. And that is what we have with our event listeners here. And that's also why I like to put the event listeners at the bottom, because they kind of follow along with, that's the arrow going out from the bottom of the state. So then we have our stop ball falling, where it removes an event listener. We don't mention that in the diagram. We wanted to keep it as simple as possible. You can always assume that an arrow here, it adds the event listener, and when the arrow is done, it removes the event listener. And this one pauses the animation falling, and it starts the animation disappear, just like we have here. And then it says when the animation disappear ends, then we call the next function, and that is our animation end. And if you write animation end disappear like this, that's also okay. This is a diagram. It doesn't have to be exactly like the code is written. The only thing that we want to make certain is that the functions are called the same. And then we have the last thing, the last function, the last state, restart ball falling. That will restart the animation. That's all of this. And it will unpause the animation that was falling. Here we remove. And whether we call it add a class or pause or unpause, whatever we call it here, as long as it makes sense for ourselves. And again, this isn't the code, this is the code, so we just need a diagram to understand what the idea with the code is. And then finally we remove the animation disappear, and that is also what we do here. And once again, if we then click on the ball, it goes to stop ball falling. So at the end here, if we click on the ball, then it goes up and can enter the stop ball falling. So this is just an idea of how a state machine diagram can represent the code you've written. And I think you'll agree that this diagram is much quicker and easier to read than all these lines of code with document query selectors strewn all over it. This was just an introduction. Later on we'll dive much more into the state machine diagrams, and you'll learn how to draw them for your own code.